Yes, this presentation explores the corrective predictive coding hypothesis and how it can be applied to understand phase transitions within multi-agent systems. The objective is to examine whether behaviors in complex corrective systems, can be effectively captured through predictive coding and active inference frameworks with potential implication for decentralized and corrective modeling in scientific context. I'm sorry. スライドをめくるのうまくいく。すいません。大変です。Yeah, okay. Yeah. And yeah, what I talk about today is, and firstly, the corrective predictive coding as active inference. And some people might consider that is it possible to describe corrective phenomena using a single agent model? Yeah, as you know, the active inference framework, the active inference or free energy principle describes a single agent's behavior. On the other hand, we'd like to describe, or the corrective predictive coding hypothesis try to describe the corrective phenomenon. So there's some researchers, some people might consider that is it possible to describe corrective phenomena using a single agent model? Yes. I'd like to answer the question. The answer is yes. The deep learning integrates the signals that generated by individual neurons to manifest a cohesive function as a whole. Similar to that, similar way that we can understand how corrective predictive coding describes the corrective phenomena using active inference framework or free energy principle frameworks. This is the first part of my presentation. And after that, I'd like to talk on the phase transition phenomena in multi-agent systems. The large corrective predictive coding frameworks models can be described the very complicated the situation like the paradigm shift because as you know some researchers knows the deep learning has a very many singular points in the parameter space and similar to that the large CPC models also has and very singular points in the parameter space. So we can understand the phase transition phenomena is similar to the jumping, the parameter spaces, the disk continuous update steps, the singular point jump steps. This is very, we can understand the scientific paradigm to the singular point jumps. And this is my second part of my presentation. So let's start the first part of my presentation, what is active inference? And at first, let's consider the free energy principle agent. It's a dog, and for dog, his external world is his dog owner. For him, the dog owner is an external world. And let's consider this situation. And the dog owner has its hidden state. For instance, the emotion or gut feelings the star symbols means fun emotion. The blank symbols means the neutral states, and the blood tubes that means the angry states. And so the dog owner has some hidden states. And uh, and after that, the dog owner decide to act her acts. For instance, she'd like to feed to her dogs, or if she angry to the dogs, she might be a punch to her dogs. Yeah. So depending on her states, her acts, some behavior, and for dogs, the for agents, the activity, the external world changes the looks, sensory inputs or rewards, and yes, for instance, the external world or the dog owner feeds to the dog, and after that, the by depending on sensory inputs or rewards, the FEP agent gets or its own internal representations. And so how can we calculate or know the FEP agent's internal representations? It's really simple, easy. The FEP agents choose its own internal representations to minimize its own free energy, some objective functions. Yes, then he choose its own international representations. So this the symbol means that his dog owner, the dog owner might be has fun emotion. Then the dog estimates the inference, its own external world states. And after that, the FEP agents select his own action policy. And also this decision process and can be described the free energy minimized process also. And after that, and also each processes the hidden states to changes that translate to the international representations. This process needs to the generative model, and also the action decision process also has another parameters. And learning or parameter optimization process is also we can consider that consider as a parameter optimization is a functional minimized process. Let's summary the whole process. The first, the perceptual inference. The hidden states of external world are inferred from sensory inputs based on the generative model. In this process, the internal representation that minimize free energy is selected. And the second, the active inference process. Through actions, FEP agent can intervene in the external environment to obtain the desired sensory input. This is known as active inference, where actions are chosen to minimize free energy. And third process, the running or parameter optimization. Alongside perception and action, the generative model itself is also updated. And this updated process is similarly determined to minimize free energy. So it's very simple. The just minimization of free energy and expected free energy minimization derives perception, action, and learning. Sorry. ありがとう。ありがとう。ありがとう。Yes. So, yes, the just minimize its own free energy and expected free energy that we can that we can derive the perception process and action process and learning process. It's very simple. Yes. Now, this is a normal, ordinary active inference framework, free energy principle framework. Uh, but we'd like to consider the corrective active inference process. And what's the difference? The ordinary active inference process and corrective active inference process is just a single term, the corrective regularization term. Then, yes, please note that the corrective regularization term cannot be expressed as a sum of terms for individual agents. The global or corrective representation W acts as an interactive force or bond that unites the entire corrective through interactions among individual agents. This is a very important variable. Yes. And yes, we will now finally move to the latter topic, the phase transition phenomena in multi-agent system. And yes, so yes, then now that we can understand the active inference frame is can be used to describe the corrective phenomena. So yeah, let's replace the ordinary FEP agent to the corrective FEP agents. It means the community or a scientific community or group of person. And then the new free energy function, objective function, has a corrective terms. It means the model has many agents, and each agents communicate with by using some symbols. And ありがとう。ありがとう。ちょっとごめんね。ちょっとごめんね。ごめんごめん。本当にごめん。and yeah. Yes, and yeah, and the global collective representation W bonds that unite each agent to interact each others, and yes, and this is very important part. Let's consider the examples using neural networks or deep learnings. If we consider the very small neural networks, then the loss landscape on the parameter, this number of parameters correlate with population size, neuronal population size or community size. And if we consider the very small neural networks, the loss landscape is very simple. It's nearly the convex function. On the other hand, the deep learnings, the loss landscape is so complicated. And in a high dimensional space, the loss landscape, the geometry is really complex, and it has the many singular points. Uh, then the same way we can understand the expansion of community size that complicates the loss landscape in the parameter space, the ultimately resulting in a vast number of singularities that evolves in its parameter space, the loss landscapes. And the vast number of singularities is very important on the learning process. Uh, the some people might know that according to the singular learning theory, with the updating of the posterior distribution of parameters, the parameters of the CPC model are discontinuously updated. The jumping from the one singularity to singular points to another singular points, the discontinuously updated the process or trajectory that happens. And then we can understanding that those learning process, the trajectory is this is phase transitions phenomena. This continuously shifts in the paradigm of the community or scientific communities. Yes, so yes, this is a summary of the point. The occurrence of the phase transitions that represented by the discontinuous shift in the dominant paradigm within the community can be understood the parameter spaces many singularities will lead the phase transitions or scientific paradigm shift. Yes, by using the singular learning theory or CPC models, that we can understand that. Yes. 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 That's all. This is my presentation.